In this video, we're going to do start section 5.4.3 on polar curves. So in rectangular coordinates, functions are usually given with y as the dependent variable and x as the independent variable. In other words, y is f of x. In polar coordinates, it is r that is generally the dependent variable and theta, which is independent. And so usually we have r is equal to f of theta. Let's look at example 5.4.6. We're going to have two curves to plot here, one of which is going to be a function, r is f of theta, and the second is not. So A, we're asked to graph the curve r is equal to 1. Well, there cannot be anything simpler than a constant function, right? That's the simplest kind of function you can have. And so if we have a constant radius, then that is describing, can't let go of my axis there, that is describing a circle, right, of constant radius 1. So polar coordinates are ideal for describing circle equations. They take a complicated circle equation, well, not that complicated, but x squared plus y squared is equal to 1 is the equation of that circle in rectangular coordinates, and they transform that into the simplest kind of constant function, r is equal to 1 in this case, or r is equal to a, is a general equation of a circle with radius a, right? So this is a circle with radius a. All right, so there is our function. R is f of theta. What if we have a constant theta? So theta is pi over 4. Well, what does that look like? That, you may be surprised, I'm having trouble with my axes here, that you may be surprised to be something that you recognize. If we have a constant angle, you remember the angle is what is made with the positive x-axis. Theta is pi over 4, but the radius can be anything. So as long as that angle is pi over 4, the radius can be anything whatsoever. And so that is a line going through the origin where that angle is pi over 4. So that line in rectangular coordinates, that's the line y is equal to x. So in general, if we have theta is equal to some constant, let's say theta 0, we remember that the tan of an angle in polar coordinates, to convert back to rectangular coordinates, we have tan of theta 0 is y equals, or y over x. And so theta is equal to theta 0 is actually always the line y is tan theta 0. In other words, tan theta 0 is the slope, x. And so this is always a line through the origin. Right? So constant theta, line through the origin. Constant radius, circle, centered about the origin. In the next video, we're going to look at a couple more polar curves with a little bit more complicated equations.